Hello, this is Gregory. Here's the way how to avoid the robot from getting stuck. Alternative to timeouts. For driving back and forward, you can use motors as sensors. The motor senses when the velocity is zero. And when your robot hits the wall, the velocity is zero. So it goes out of the loop and goes to the next action. For instance, let's drive this robot to the wall, and then it will retract this pneumatic toucher. But it can be any other action. It's just an example. So first, you need to set velocity. And start reverse. Then, a little bit during the drive. It will still drive. It will wait until it accelerates and until the velocity is not zero. Or robot will never start. It will say velocity zero, and I'm done. Wait like 200 milliseconds. But you can adjust this number. And then that's the main part. That's the loop. It will repeat adjusting the direction, or it will just, you don't do PID. But for proportional driving PID, you just adjust it and repeat it until velocity of one of zero. And when velocity is zero, when the robot hits the wall, it stops doing it, goes to the next step, will and do something. In this case, it's of the cylinder. Let's see how it works. Okay, so now I'll go to the robot and activate this program. Okay. I have to start the program. Haha. Now I can activate. Yeah, see, the robot did exactly what it was supposed to do. It hit the wall, stopped, and performed an operation. It extended the cylinder. Now, a similar problem is with a catapult. So if catapult hits the floor, it gets stuck and the robot gets stuck. However, this way will not work for the catapult because when it hits the wall, it will push against the wall and it will slowly reduce the speed. And by the time the velocity is zero, your robot will be crooked. And adjusting some intermediate velocities doesn't also work in a reproducible way. It doesn't give you any advantage. But the solution is placing a bumper sensor on the catapult. So if you look at this robot, let me just drive it closer. Oh, yeah. So you can see that I'll use a mouse here. Here is a sensor, bumper sensor. And then the catapult goes down, it hits a plate that you adjust the height. And the height is adjusted when the bumper hits the plate. Well, the bumper is hit and the robot feels it. So now let's program it and see how it works. Okay, so we don't need this part anymore. And this program is actually much simpler. You just spin the shooter forward until the bumper is hit. That's all. Then you stop it and do something. And in this case, the other action is driving back for a certain distance. In this case, precise back. Let's download it and see how it works. Okay, so now I'll activate it. And maybe I'll drive a bit forward to give it some room for going backwards. Okay. Let's do it. Perfect. So the robot completed the action and the catapult, it stopped at the right position. It's not even dragging on the floor. And if you do it several times, you get same perfect result. And then the robot goes to the next action, precise back. Thank you for watching.